Hi everyone. In this video, I'll be going over the solution for the first homework problem. We'll begin with the Kelson sporting equipment problem. I'll quickly go over the formulation, then we'll try to see if I can do this on how I can solve this with graphical solution on the screen, but we'll get to that in a second. Okay. Let me say blank slide and then maybe put some text box in there. All right. So as far as formulation is concerned, let's begin with the first portion. So the problem says you're making two types of baseball gloves, regular model and catcher model. The firm has 900 hours of production time for cutting and sewing, and 300 times for the finishing, and 100 hours for packing and shipping. So this is again very similar to the tables and chairs problems that we did. Instead of having two different departments, you have three departments. That's pretty much the only difference. So we have two models here, the catcher's model and the regular model. So let's begin with decision variables. We say D is, R is the number of regular model gloves made. And C is number of and C is the number of catcher's gloves that are made. All right. And those are our decision variables. The objective is to maximize profit. We know the profit values that are given to us here. If you look at it, it says each regular model glove has a profit of $5. Catcher's model glove has a profit of $8, right? So maximize profit. So regular model is 5 times R plus 8 times C, right? So maximize 5 times R plus 8 times C. That's your objective. Now for the constraints. Again, I'm going through this quickly. In case you have any questions, feel free to email me. All right. So we have how many hours? So 900 hours for production for cutting and sewing, 300 for finishing, and 100 for packing and shipping. So 900, 300, and 100. So it's good that the times are given to us directly in hours, and we don't have to. They're not given in minutes, and having us to convert, making us convert them into hours. So if you look at the constraints, so the constraints are going to be pretty straight. Not Excel, I'm sorry, PowerPoint. So if you look at the constraints themselves, they should be pretty straightforward, right? So move stuff around a little bit. So this is so a 1 hour for a regular model. So cutting and sewing, 1 hour for a regular model glove, 1.5 hours for a catcher model glove. So the first constraint will be 1 times R, right? So I'm just going to say R plus 3/2 of C. This is the total time required to make all the to cut and sew all the gloves that you have, and that's less than or equal to 900 hours, right? And then next is cutting and sewing is 900, right? And then 300, then 100, right? And finishing is a half hour for a regular glove and 1/3 hour for a catcher's glove. So it's half R plus 1/3 C is less than or equal to 300. And finally, it is 1/8 R plus 1/4 C is less than or equal to 100 hours, right? That's how much time we have available, 100. Okay, right? So apart from this, we have the usual C and R have to be greater than 0. They have to be full numbers, because whole numbers, because we cannot have half a glove and expect to make half the price and profit, right? So because there are a lot of denominators and stuff, I'm just gonna convert these constraints into slightly better looking constraints. You don't have to do this, but I mean, I'm just doing it because I don't feel like having anything in the denominator. So if I multiply this whole constraint out by 2, I will end up getting, so 2 times r, right? Why did I choose 2? Because this has a 2 in the denominator. It's 2 times r plus 3 times c is less than or equal to 1800, right? So that's my first constraint. Next. Right? Next, so this has a 2 in the denominator, there's a 3, so we multiply the whole thing out by 6. So this is going to be 3 times r plus 2 times c is less than or equal to 1800 again, right? Multiply the whole thing by 6. So it's 2r, 3c, 3r, 2c, and then, right? And then this is 1/8, this is 1/4, so I'm just going to multiply the whole thing by 8. So it'll give me r plus 2c is less than or equal to 800, right? That's my other constraint. So I multiply the whole thing out by 8. So it'll be r plus 2 times c is less than or equal to. So the reason to do this is that it's much easier to plot these than to do this. I mean, not that is that difficult, but hey, they look better to me. All right, so now let's see how I can plot this. So I'm going to try this out. All right, so new slide. Okay, let's do this first, right? So let's have a y-axis. I'm going to have a y-axis like that. Just wanted to get the direction right. And then now let's have an x-axis. All right, so I have my x and y axes here. Now what I'm going to do is I'm going to draw here. No, before we do that, let's find the endpoint. So one thing, one good thing to do, especially when you have constraints like these, is to figure out where the endpoints are going to be, so we know how to scale our x and y axis. So in this case, the r and the c axis. So if you look at the endpoints for 2r plus 3c is equal to 1800, right? So if I plug in r is 0, I'll get 3c is 1800 or c is 600, right? So the endpoints for this will be 0, 600. So r is on the x-axis and c is on the y-axis. So 0, 600 and 900, 0. So these are the two endpoints. Now for the other constraint, again, it'll be just flipped over, right? Because we have 3r plus 2c is 1800, which is the same as saying 0, so if I plug in c is 0, I get r is, so it'll be 600, 0 and 0, 900. I'm just going to move these around. I like having the x coordinate first. Sorry, the x intercept first. Okay. There you go. So those are the endpoints for the first two. Now let's find the endpoint for the third one. Okay. So if I plug in r is 0, I get 2c. So I get 0, 400 here. I think I made a mistake, so let me fix that in a second. So 0, 400. And then if I plug in c is equal to 0, r is 800. So it'll be 800, 0. Now, I think the mistake that I made is I think the last constraint is a greater than or equal to constraint. So let me look at that. So see, don't make the same mistake that I made. All right, so let's read this. It says, right, so two different types of models. So the firm has 900 hours of production time available. cutting and sewing 300 times the finishing department, and 100 hours available in packaging and shipping department. The production time requirements are given here. What is assuming the company is interested in maximizing total profit contribution? What is the no, you know what, I had this right. No problem there. All right, so let's plot this. Right, so this is where we get. So on the x-axis, you'll notice that the good thing about getting all the endpoints is that, sorry, the endpoints of the straight lines is that now I know that on the x-axis I have to mark a 600, a 800, and 900, and on the y-axis I have to mark a 400, 600, and 900. So I'm still going to make two marks that are 200 apart. So I'm going to say 200, 400, 600, 800, and 1000. Again, they're obviously not to scale, but I mean 200, 400, 600, 800, and 1000. Right. So with this, so let's look at the first for the first constraint. The endpoints are 900, 0, 0, 600. So if I put that down, 900, 0, so that'll be somewhere here, and 0, 600 will be right there. Right. So let's see if this will work. Right. I'm gonna start here and end there. Right. So now everything within this triangle is my feasible region. Why? Because if I take 0, 0 and plug it into the constraint, I get 0 plus 0 is less than 1800. So because one point on this side of the line satisfies this constraint, all points on this side. So that's my current feasible region. Let's go to the second one. So it's 600, 0, 0, 900. So 600, 0 is right there. Oops, sorry. No matter, that's fine. So 600, 0 is here, 0, 900 will be somewhere over there. So let's do that, right? So we have that right now. And finally, we have 800, 0, 0, 400, right? So 800, 0 is here, and 0, 400 is over there, right? Yep, that's my constraint right there. Now, so one thing I want you to notice is that you have this line here, so everything on this side of this line. The second constraint was here, so everything on this side of the constraint. And the third constraint is all the way down here, which means we are looking at everything inside this constraint also. So if you notice, this constraint here is completely within the feasible region of this constraint, which means that this was actually a redundant constraint. You could have worked without this, because right now, if you look at the feasible region, right here, this here is the feasible region. Everything here. Right? So that's my feasible region. Right? So that's my feasible region over there. So this constraint here, the second constraint that I do, was essentially unnecessary. Even without that constraint, the feasible region would have been the same. So it is a redundant constraint. So with that in mind, our endpoints will now be this point here, this point here, and this point here, right? So let's find these three, and then we are good. So this point is pretty straightforward. That is 400, 0. So our endpoints, one of them is 400, 0. So you know what? Let's insert a new slide. Right? And profit is 5R plus 8C. So I guess I didn't need this. Okay, so 400 comma 0 400 was one of the points. 0 400 is right there, right? 0 400, and the other endpoint is right here, 600 comma 0 600 comma 0. So these two constraints essentially represent, if I just made catcher's gloves based upon the constraints I had, the maximum I can make is 400 of them. If I just made regular gloves based on the constraints I have, I can only make 600 of them. Now to find the other combination, this is the point of intersection of these two lines right here, which was my very first constraint that I had, and the very last constraint that I had, right? So for the first constraint, the one with the 900, yeah, I think 0 900, that's the one that I want. In fact, that's a second constraint, right? 0 900, and this one is 600 0 600 0 0 900. Yep, this is the one. So it's the last two constraints. I'm sorry, it's the point of intersection of these two constraints right here. So let's find these two straight lines right here. So let's find the point of intersection. So it's 3r plus 2c is 1800, and r plus 2c is 800. This actually should be not that difficult to solve. So you have 3r plus 2c is 1800. Then you have r plus 2c is 1000, right? Or was it 800? I'm sorry. So I can directly subtract the two equations because this is 2c, this is 2c. So if I subtract the second equation from the first equation, I end up with so 3r minus this would be 2r is equal to 800, and r is 400, right? So r is 400. I can plug that into any one of the equations. I'll plug into the second one. It'll be 400 plus 2 times c is 800, right? So this implies that 2c is 400 or c is 200, right? So it's 400 comma 200. So if I go back here, it'll be about 400 comma 200. So like you see, I mean, this, I didn't draw this to scale, so you cannot have guessed the answer here, right? So 400 comma 200 is the other one. So 400 regular gloves, 200 catcher's gloves. So what is the profit here? So if I'm not making any regular gloves, only catcher's gloves, that'll be 8 times 400. That's $3,200 in profit. If I only make regular gloves, there'll be $3,000 in profit, right? 600 times 5. Here it'll be 2,000 plus 1,600, so 3,600, right? And there you go. That is, so the optimal solution here is to make 400 regular gloves, 200 catcher's gloves, and make a profit of 3,600, right? That's it, right? I'm going to stop this right here.